So we are looking at this one. It says simplify the square root of 4. When we look at the square root of 4, we're looking for two numbers that are the exact same that multiply to equal 4. So what multiplies by itself to equal 4? 2 times 2 equals 4, so the square root of 4 is 2. Same thing here. What multiplies by itself to give you 64? 8 times 8, so the square root of 64 is 8. This one says between which two consecutive integers on the number line is the square root of 30 located? Select the two locations on the number line to plot those points by shading in the circles. So we're looking for the two integers that it lies between, which means we need to know the two perfect squares that 30 lies between. So what comes before the square root of 30 that's a perfect square? That would be 25. And then what comes after 30 that's a perfect square? That would be 36. All right, now the square root of 25 is 5, and the square root of 36 is 6. So that means that the square root of 30 would be between 5 and 6. Same thing, we're doing the same thing here, but we're going to try to estimate it a little bit better. So this was, it wants us to pinpoint the location of the square root of 110 without using a calculator. So we're looking for the perfect square root that comes before 110, which would be 100. And then we're looking for the square root that comes after 110, which would be 121. Now the square root of 100 is 10, and the square root of 121 is 11. So it wouldn't be what comes before 10, it wouldn't be what after that. It would not be what comes after 11. So now we look and we want to see if it's closer to 11 or closer to 10. Well, when we look, it is 10 away from 100, and it's 11 away from 121. So that means it is closer to the 100 than it is to the, it's closer to the 10 than it is to the 11. So it would be K. The next one says to select the irrational numbers. Remember, irrational numbers have decimals when put into decimal form that never repeat or end. So go ahead and pick your two irrational numbers. The first one would be pi, because when pi is one that just goes on forever and ever and ever. It's 3.14, and then all of that comes after. 1/4 is not one. First of all, if it can be written as a fraction, it's a rational number. But also when I put it into a calculator, it gives me 0.25, and that decimal definitely doesn't go on forever and ever and never repeat. And then 1/3 is already written as a fraction, which means it's a rational number. But also if I put this into the calculator, yes, this will go on forever and ever and ever. However, it repeats. So that one doesn't fit. -4 definitely ends. It doesn't even have a decimal. And 1.5 definitely ends. It doesn't have a decimal. When we put the square root of 2 into a calculator, we get 1.4, and that goes on forever and ever, ever. Remember, if it's not a perfect square, it is an irrational number. Then this one says define irrational numbers, and I literally defined irrational numbers over here for you. So all you have to do is just write that definition down. And here's that definition. Oops, that should still be circled. This one says the diagram shows the relationship between several sets of numbers, indicate the set to which each number in the table belongs. So we're looking at the square root of 63. So is the square root of 63 a rational or irrational number? This would be an irrational number because it is not a perfect square root, and only perfect square roots can be rational. Also, if I put it into a calculator, that is the wrong button, it would give me a long decimal, and that decimal would just keep going on. Is the square root of 36 a rational or irrational number? Well, this is a perfect square root, which gives me 6, so that definitely terminates, and that is a rational number. Is -1.3 repeating a rational or irrational number? This one is rational. Remember, it can be rational if the decimal repeats, and in this case it does repeat, so that makes it a rational number. We could actually write this as a fraction by saying it's -1 and 1/3, and if it can be written as a fraction, it's rational. Then we have pi. Is pi rational or irrational? Pi is irrational. Remember, it's always irrational. And then we have 9.245 ... That ... means it goes on forever and ever and ever. And in this case, does it look like it's repeating? It's not repeating, so this is an irrational number. It goes on forever and ever, and it never ends. This one says the Venn diagram shows the relationship between different sets of numbers in the real number system. Where should negative square root of 81 be placed in the diagram? Negative square root of 81 equals what? It equals -9. And we could put that into our calculator if we wanted to check. And that gives us negative 3. Sorry, I put the wrong thing in there. Negative square root of 81. I don't really know what's going on here. Negative square root of 81. Okay, there we go. And that gives us negative 9. Now, negative 9 is a what? It is an integer, because remember, our integers are our whole numbers that have negatives. Okay. This one says, between which two whole numbers does the square root of 182 belong? So, knowing your perfect squares, where would the square root of 182 fall between? It would fall between 169, which is 13, and then 196, which is 14. So it would fall between 13 and 14. If you don't have those memorized up to that point, you could know that you could type this into the calculator and it gives you 13.4, which is between 13 and 14. This one says fill in the blank with the inequality symbol. So we want to put 38 over 7 as a decimal. So when I do 38 divided by 7, that gives me 5 and remember we go out to the third decimal place. So that gives me 5.428, but this 5 is going to turn that 8 into a 9. And then we have the square root of 18.5, which is going to give me 4.301. So when we compare these, which one is bigger? This one over here is bigger. All right, this one says to place the orders in number of greatest to least. So what we're going to do is we're going to put these in decimal form. So we do negative 41 divided by 5 in our calculator for this, and that gives us negative 8.2. But I want to give it 2 more zeros so it can go out to the thousandths place. And then we'll take the square root of 37, and that gives me 6.0827, but that 7 is going to round that 2 up to 3. And I have negative 27 divided by 6. Negative 27 divided by 6. Which is going to give me negative 4.5, but we're going to add 2 decimals on. So we'll do 0.00. And then we'll see what pi is. Pi is going to give us 3.1415, but this 5 right here is going to turn that one into a 2. And then we just have straight up 0. Okay, now remember, we have positives and negatives going on here. So which one is small, the positives or the negatives? The negatives are going to be small, so we'll focus on those first. So we're looking here and we're looking here. Now remember, the more negative it is, the smaller it is. So which one out of those two is smaller? That would be the negative 8.2, because that is more negative than negative 4.5. So we're going to put negative 41 over 5 here in the least category. And then after that is going to come the other negative number, which is negative 4.5, which is negative 27 over 6. After that, we're going to X these out, and we're left with the other numbers. What comes next? 0 would come next, because 0 is less than 3 and it's less than 6. And then after that, what would come next after that? That would be the 3.142, so that's pi. And then that leaves us with the square root of 37 as our greatest. Okay, this one says a list of numbers is ordered from greatest value to least. One number is missing. So what we're going to do is we're going to look for the numbers that is between 4.81 and then the square root of 27 gives us 5.196. So we're looking for the number that's between 4.81 and 5.196. So we're going to start with 67 over 15, which is going to give us 4.4666, and this 6 right here is going to change that 6 into a 7. And then we just have 5.5. I'll tack 2 zeros onto that. And then how do we turn a percent into a decimal? We take this decimal and we move it over 2 times. Into this blank right here is going to go as 0, so that's 0.049. And then we have 2.2 squared, so I would do 2.2 and then hit the square, 2.2 and then hit the squared button. It's going to give me 4.84. So when we look, We're looking for something that's bigger than 4.81. So we have two numbers that are bigger than 4.81, B and D. We are also looking for something that is smaller than 5.196. So which one is it, B or D? We're going to be left with D. And that's it.